Welcome to the sky this month. I'm your host, Dave McDonald. We'll be talking about the ending of March, beginning of April, neat things going on in the sky. We have the 30th anniversary of Hubble Space Telescope. We've got the 90th anniversary of the discovery of Pluto. And there we will be having a special program at the McAuliffe Shepard Discovery Center on Friday night, April 3rd. And there you can see Pluto, the best image taken of Pluto with its moon Charon just behind. And we're going to celebrate the 90th anniversary of Pluto's discovery, April 3rd. That's 7 o'clock at the McAuliffe Shepard Discovery Center in Concord. And I'll be presenting that program. Don't miss it. Come on down. All right. So this is the season of the equinox. It's March, and a little earlier than you might expect. It's March 19th this year at 11:50 p.m. Eastern Daylight Time. So what makes it the equinox? Well, let's look at this image, and you can see Earth going around the sun, and you can see how the shadow is changing, and you can see how the tilt of Earth is changing. And at the top of the picture, you can see the tilt of Earth's axis towards the right. And you can see how the sun's rays are direct onto Earth. That tilt is 23.5 degrees. And that's what our Earth is going to look like as the sun crosses the equator. So this next image is going to show you the views from the International Space Station. You see 4 views of Earth during the seasons. And so you can see how Earth is tilted, but on the right side, you can see at the equinoxes, you have, so to speak, the terminator line appears to be straight. So as Earth turns, we have light from the North Pole all the way down to the South Pole. Whereas you can see in December, in the top left, that the North Pole is in darkness, and then below it, in June, we have the South Pole is in darkness. So that's kind of a view from space of what the equinoxes look like. And a neat thing that you get to do on the equinox is on the equinox, you can actually balance an egg on its end. So I had some students at school do this, lying on the floor where it's nice and flat. And so you can see she has just about 4 eggs balanced on their end at the same time. And this next image, you can see it's in progress. They're working on getting it in progress. And then I had a student ask me, can you balance it on the narrow end? And this young man, his name's Kyle, actually balanced the egg on its narrow end. Hard to believe, but it can be done. So give that a whirl on Friday, March 19th, okay? That's going to be a lot. On March 19th is going to be your opportunity to try it. And probably since the equinox is at 11:50 p.m., you might have some luck on the next morning also. Friday is Thursday, and then on Friday morning, the 20th, you may have some luck at doing it then as well. All right, so now check out this next image. So what actually, astronomically speaking, causes it to be the equinox is when the sun, which travels along what we call the ecliptic by definition is the pathway of Earth around the sun, but since we're on Earth, to us, it appears to be the path of the path of the sun around Earth. And you can see the celestial equator there. And what happens is, on the equinox, is the sun crosses the celestial equator and will be working its way northward towards the solstice. So this is an image of the sun. We've taken the atmosphere away, so we don't see the blue sky there. But this is what it's looking like on March 19th as the sun crosses the celestial equator on its way north. Pretty cool. Well, as I already mentioned to you, it is the 30th anniversary of the Hubble Space Telescope, and I have a guest with me. Cody York is with me. So, good to see you.
Thanks for having me back.
You are welcome, and Cody's no stranger to our show. And so, Cody, it is the 30th anniversary of the Hubble Space Telescope.
Yes, it is.
And I asked you to come up with Cody's top 5. What do you have for us for the top 5 images that you found that help us celebrate the 30th anniversary?
All right. So the first one that I have here is this picture of Mars. Figured that we would start somewhat close to home. And now these were both taken at opposition, so it's when the Sun, the Earth, and Mars are in line with each other. There's one in 2016 and one in 2018. The interesting thing to note here is that in 2018, you can see that there were dust storms more heavily than in 2016, as well as the fact that the tilt is slightly different. So in 2016, it was a lot more towards the warmer seasons in like spring and summer in the northern hemisphere of Mars, because it's tilted towards us. And in 2018, it's about equal. This was about springtime on Mars when this happened. And I just thought it was interesting that even with 30-year-old technology, it can still get images this sharp. The next image.
Well, if we can go back to the Mars, just an observation there. On the right, it doesn't look like the land masses are quite as clear. If I remember right, in 2018 there was a dust storm.
Yes.
And so I think what the reason we're seeing a little on the cloudy, not so clear side is because of the dust storm that lasted for a few months.
You see that a lot. As you can see, it's closer to the South Pole. There's a cloud. If you look to the bottom right of 2018, usually dust storms happen on Mars near the South Pole during the warmer seasons.
Yeah, very interesting. And so amazing pictures. Again, the Hubble Space Telescope orbiting Earth gets these amazing images. All right, so what do we have next, Cody?
So the next image we have here is a star-forming region, S106. It's in the constellation Cygnus. And here what we can see is, you can see the contrasting colors in the nebula, the blue and the red, both of which, of course, are on the hydrogen emission spectrum, because most of these formation zones are made of hydrogen, because that's what most stars burn in the main cycle of their life. Now you can notice that it's been nicknamed by NASA scientists as the angel, because if you see the blue parts as the wings and the red part as the body, it's definitely interesting. So this is where we see, of course, blue being the hotter section, we see the blue sort of condensing a little bit in order to form stars, to form a gravitational mass of gas and dust that eventually can become a star. And another star-forming region that I have a picture of here is located in the Large Magellanic Cloud, which is not visible in the northern hemisphere, but it's a satellite galaxy of the Milky Way. And here you see a lot more of that blue, so there's definitely a lot more of that hot energy. And as you can notice here as well, it's also many, many light years wide, so these are not small objects in space by any means. The next image that I have is of the Whirlpool galaxy M51. And this galaxy is about as standard as it gets for a spiral galaxy. I chose this image because I like the color contrast between the red and the blue and the white towards the core of the galaxy. And our Milky Way is, of course, similar in that it's also a spiral galaxy.
One thing that I find really interesting about this Whirlpool galaxy image is that it is so detailed. And you can go onto the site, Hubble site, HUBBLE, SITE. And you can see these images and you can get really, really amazingly high resolution images. And if you zoom in on the image that Cody showed us, and we're going to see it again briefly, it's amazing that this galaxy is so far away, but you can see the individual pinpoint stars in the galaxy. Again, Hubble is just absolutely amazing at its ability to be able to resolve objects that are really far away and create tremendous color that we can enjoy as well. So let's just have another look at that image.
And it's funny you should mention that about clarity as well, because when Hubble first launched, first images that came back were not very clear. And people were kind of wondering why. It was because it was an international collaboration. There was a difference between the units that were being used, the US standard units versus the metric system, this is a major reason why in scientific work you use the metric system exclusively nowadays. The last image I wanted to show is of the Crab Nebula in Taurus. What's interesting about this is that it's false color, but it's an infrared image. And I thought it was interesting because it shows that Hubble can not only see into our visible light spectrum, but it can see a little bit past what we're able to see. And then we can put that image together based on the energy waves and assign a color to it. So I just thought that was interesting.
Yeah. Well, I think that's a pretty good selection of photos from the Hubble Space Telescope that you selected. And so we have also a video clip to show you, which is, again, you can go to the Hubble site and hubblesite.org, and you can also download this, watch it again. But this is going through, I think, 600 images to music, moving really fast, but you'll just see some of the amazing, amazing photographs, images that Hubble has taken. It's less than 3 minutes, and we've got some good music to listen to. So let's roll this video. So I hope you enjoyed that video clip. It's really amazing, all the photographs. And again, that was just 600 of thousands and thousands and thousands over the 30 years that Hubble has taken. And the nice thing is, Hubble is still working, and hopefully, for a few years to come. And then we look forward to the launching of the James Webb Space Telescope, which should be coming up in the next year or two. Originally, it was going to launch 2014, and difficulties and difficulties. So hopefully, again, in the next year or two, James Webb will get launched, and it's going to be out there 1,000,000 miles from Earth. So no hope of any repair mission. And unfortunately, because we have now grounded the space shuttles, they're at museums now, we don't have any way to get back to the Hubble Space Telescope either. It's about 400-ish miles above Earth in its orbit. And when it's done, when it gives up the ghost, so to speak, it's going to be done. But it's done amazing work for us, and hopefully we'll get some more years use and service out of it. What an amazing instrument, named after Edwin Hubble, who back in the 1920s was the one who, in looking at, in particular, the Andromeda Galaxy, saying, I don't think that we're alone, because the prevailing thought up to the 1920s was that our galaxy, the Milky Way, we're it. And Edwin Hubble begged to differ and said, I think that the Andromeda Galaxy, is another galaxy like ours, far, far away. And now we know that to be true. Andromeda Galaxy is 2.5 million light years away. And now we have galaxy upon galaxy, literally trillions of galaxies, which are just amazing. And Cody and I showed you just a couple of those. But what a treat. So check out Hubble site, and you'll see some more amazing images taken by the Hubble Space Telescope. So Cody, this is March, and March 14th is Pi Day. Mm-hmm. So I'm looking forward to having some pie on Pi Day. We have a special event happening in Pennacook on Pi Day. So it's at the old BD Electric building right near Merrimack Valley High School, and we're going to be celebrating Pi Day there. But something else of note happened on March 14th years ago.
Yes, Albert Einstein was born. He's a man who's definitely probably one of the most important people to astronomy. His contributions to relativity and the idea of space and time. And I'm sure we'll hear more about him when we do the show in May, about how his theories were proven.
Yes.
But I thought it was worth mentioning that March 14th, Pi Day, was also Albert Einstein's birthday.
I think that's very cool and very appropriate. So enjoy pie on Pi Day, and put a birthday candle in your pie in honor of Albert Einstein. And so that would be very cool. I'm just trying to think in my head quickly, how old is he? Well, it was 1879, so we got 21 years there, and then we got 100 years, and we got another 20. So how many is that, 149?
141.
141 years old. Happy birthday, Albert. Okay. So amazing things are happening in the sky, and I'm going to take a little tour with you and show you where you can find some of the planets, particularly in the morning sky. Is going to be amazing. Mercury is at a point we call its greatest western elongation, and that's going to be happening on March 23rd, and that means it's going to be as far away from the sun as it can get, but the ecliptic also is at an angle, so it's still going to be a trick. I'll show you where Mercury can be found, and we also have Mars, Jupiter, and Saturn in the morning sky, and a couple of those mornings the moon is going to be paying a visit, which is awesome. Venus is available any night. It is just so bright in the western sky after sunset. You can't miss it. It's up for a few hours. And Venus is going to be reaching what we call its greatest eastern elongation on March 24th. And so after March 24th, it's going to be slowly sinking back down into the sun, but it takes a while. So blazing Venus at a magnitude about -4 in the western sky. And now we have some spring constellations that I want to show you about. But first, again, Cody, thank you very much for
Thank you.
for joining us and talking about the anniversary of Hubble.
Thank you.
You're welcome. All right, well, let's take a look at the night sky and what's going on there. All right, well, I hope you enjoyed those images from Hubble. So what's going on in the night sky with the planets? Well, this is actually the morning sky, and we're looking at March 18th, about 6 o'clock in the morning. So you can see here that the sky is starting to get light because the sun is getting ready to rise. And look at the sky way down there. Mercury, so close to the horizon. But if you can find it when it first appears, as time goes on, because we're looking east, it's going to be rising and getting higher and higher, but the sky is going to be getting lighter and lighter. So binoculars can help you keep track of Mercury, which, as I mentioned earlier, will be, this is the 18th of March, and a few days later, it'll be a little bit higher in the sky as it reaches greatest western elongation. So Mercury is available if you got a really flat eastern horizon there. But the talk of the town, so to speak, is these guys here. You've got Jupiter, Mars, and Saturn. And the reason I chose the 18th is so that you can catch the view with the moon in the same frame. So what a great picture. You got 3 planets and the moon on March 18th. Now, on the 19th, it's going to look very similar. The planets are not going to be moving too much. The moon will be down here, okay, just a little bit below Saturn is where the moon will be on the 19th. So that still will be a very nice, a very interesting, pretty picture for you to have. So that won't be bad at all. So then you have Mars hanging out right close with Jupiter, the 18th, the 19th. And then towards the end of the month, well, at the very end of the month, on March 31st, Mars will have made its way down to Saturn and will be hanging out with Saturn right at the end of March, beginning of April. The moon will be out of the picture by then because, as you may remember, the moon moves about 13 degrees from night to night at the same time. Or if you hold your fist out in front of you, and you put your pinky side against the moon, against what you might consider to be the left side as you look at it of the moon, where your thumb is where the moon will be tomorrow night towards the east. So that can kind of give you an idea of how the moon moves. The moon rises in the east and it sets in the west, but its actual movement against the stars is from west to east. And so that's pretty cool. So that's what you're going to see in the morning. Let's take a look at another date. We're going to jump to about 9 o'clock at night on the 24th of March. And the date really doesn't particularly matter, but this is about 9 o'clock or so at night. And I wanted to show you some of the neat things that you can find in the night sky. So Orion, you can see here, Orion's belt, you have Alnitak, Alnilam, and Mintaka. The upper left, as we look at Orion, is the star Betelgeuse, and the lower right, as we look at Orion, is the star Rigel, which is a bluish-white star. So we're getting into spring now. Orion is technically a winter constellation, but it's going to just help us orient ourselves because it's very easy to find. So if you look above Orion, you're going to find the stars Castor and Pollux. And the Castor and Pollux are what we know as the twin stars. And they are the stars that are representing the heads or the eyes or the neck of the twins. Gemini. Okay? Then we have Cancer, which is kind of a dim constellation, and then we have Leo the lion. So to show you Leo the lion, we have, can you see this backwards question mark here? Kind of looks like a sickle, something that you would chop down wheat or in a field. But it's this backwards question mark, and that represents the head of the lion. Regulus here represents the heart of the lion, and then back off, just off the screen here is a triangle which represents the tail, the hind legs, and the tail of the lion. Typically, he's drawn lying down, and that's Leo the lion. Now, in between Leo, this is Leo's head, and then we have the twins. We have this darker area, but there are some stars there that represent the constellation of Cancer, the crab. And if you look real carefully, in this middle portion, right between Pollux and Regulus, in this area here, you can see there's just a little bit of a glow there. And a dark, moonless night, it will be actually fairly easy for you to pick up the glow here between Gemini and Leo. And that is called the Praesepe, or the manger. And then when we had optical instruments able to kind of zoom in and look at this fuzzy spot, turned out to be a lot of stars that have now been nicknamed the Beehive Cluster M44, which looks like a bunch of busy bees. If you can get your hands on some binoculars, binoculars are great instruments to have to enjoy the night sky. Look at the Praesepe, look at some of these other star clusters that we've talked about, and obviously we'll be talking about in time to come. Binoculars will help you find the planet Mercury and some of these other objects that we've been talking about. So a great investment if you can get your hands on some nice binoculars. All right, then down here we have the star Sirius, which is the brightest star in the nighttime sky in either hemisphere. And if you take Orion's belt and you go downwards, we come to Sirius, which is the big dog star. And then between Pollux and Sirius, we have another bright star, which is Procyon. And Procyon is the little dog star. And you can see the star right up here. So those two stars make up the little dog. Now, I don't see much of a dog there, but I can make out a hot dog there. So perhaps that's what it's intended to be, is a hot dog. Then Sirius is part of the big dog. And in the middle here, again, more dim stars. You may want to look this up so you can kind of see what it looks like. But in between Procyon and Sirius is, believe it or not, a unicorn. Monoceros is a unicorn that is between the big dog and the little dog. So pretty interesting. Now let's look at this last image that I have for you here, which is a quick peek at Venus. And we're looking towards the west now. You can see that over here, there's Orion the hunter that we've talked about. And if you take the three stars in Orion's belt and go upwards, we come to Aldebaran, the brightest star in Taurus, the bull. This V shape is the face of the bull. And we have this star cluster called the Pleiades. In Japanese, it's known as the Subaru. And then Venus. Venus blazing brilliantly. And this is around 8 o'clock or so at night on the 24th. And you can see Aldebaran, the Pleiades, Venus, really pretty, really bright. And so just a couple of things to wrap up to remind you that Friday night, April 3rd, at the McAuliffe Shepard Discovery Center, we'll be celebrating the 90th anniversary of the discovery of the planet Pluto. That's 7 o'clock, Friday night, April 3rd, at the McAuliffe Shepard Discovery Center in Concord. And then also, we are going to be celebrating Uri's Night, or Uri's Day, on Saturday, April 11th, at the Discovery Center in Concord. We're going to be showing a couple of special shows called The Dawn of the Space Age, which is an amazing show that kind of documents how the space age started with Sputnik And then Yuri Gagarin, who's the first human being to go up into space, was Russian. And there's this big deal around the world, it's global, called Yuri's Night. And that technically is April 12th, which this year is Easter Sunday. So a lot of places are celebrating it on the Friday night or Saturday night. And at Belmont High School in New Hampshire, Belmont High School, New Hampshire, on the Saturday night, April 11th, there'll be some telescopes. We'll be having a little bit of a program there. So if you can make it there at night, that'd be great. During the day, Saturday, April 11th at the McCall Shepherd Discovery Center in Concord, dawn of the space age. You don't want to miss it. At 1 o'clock and 3 o'clock will be those special shows. So that wraps it up for this show, and we'll look forward to seeing you next month. I'm Dave McDonald.